Welcome. Today we're going to be going through the 2012 Cape Pure Mathematics paper. Nice and easy. Let's start with question 1. Question 1 says f of x is 2x cubed minus px squared plus qx minus 10. So let's write that down. We have f of x is equal to 2x cubed minus px squared plus qx minus 10. Now let's hear what they say next now. The next thing that they say is, and it is divisible by x minus 1. If it is divisible by x minus 1, then they're telling us that f of 1 is equal to 0. Now if f of 1 is equal to 0, what does that tell us? If f of 1 is equal to 0, we can substitute 1 into f, and we're going to get 2 times 1 cubed, which is 2, minus p times 1 square, which is just p, plus q minus 10. They're telling us that that is of course equal to 0. So I'm just going to rewrite it this way and say then we have minus p plus q, and that's equal to, when I bring over 2 minus 10 is minus 8, so when I bring it over it is positive 8. And let's hear what they say next. They say now it has a remainder of minus 6 when it is divided by x plus 1. So what they're also telling us is that f of minus 1, because if x plus 1 is a factor, then it's f of minus 1. They're telling us that f of minus 1 is equal to negative 6. If f of minus 1 is equal to negative 6, then what they're telling us is plug in minus 1 here. Minus 1 cube is minus 1 times 2, which is minus 2. Minus 1 square, which is 1. 1 times minus p is minus p. Then 1 times q, minus 1 times q, that's minus q, minus 10, and that's equal to negative 6. Nice. So now what we end up with is two equations. I'm going to rewrite this as minus p minus q, and that is going to be equal to minus 2 minus 10 is minus 12. When you bring over minus 12, it becomes plus 12. Plus 12 minus 6 is 6. All right. So what I'm going to do is group the two equations. I'm going to put the first equation below this second equation here. So we have minus p plus q is equal to 8. Cool. Now, let's say you wanted to add them together, right? If you add these two equations together, what's going to happen? If I add them together, I'm going to get minus p, which is minus 2p. Then I'm going to get minus q plus q, which cancel. And 6 plus 8 is 14. If I then divide through by negative 2, I'm getting that p is equal to 14 over negative 2, which is negative 7. So that's how we get p to be negative 7. Once we get p is equal to negative 7, what can we then do? We can then substitute to find q. Now if p is negative 7, look right here. Negative 7 is 7, plus q is 8. And so q must be 1. Q is equal to 1. So that takes care of the first part by finding the values of p and q. So that's part 1. P and Q. P is -7 and Q is 1. Nice. That takes care of part 1. Now part 2, of course, is going to ask us to factorize. All right, so let's go ahead and do part 2. So for part 2, factorize f of x. Since we know what P and Q is, we can rewrite f of x now as f of x is equal to, it is now 2x cubed. Instead of writing minus px, it is actually minus 7, which become plus 7. So it is now plus 7x squared plus qx, but q is 1, so it's just plus x minus 10. All right, so this is f of x. Now, we can go ahead now and do our polynomial division to find the quadratic factor of f of x. So let's do our polynomial division. Remember, it told us that it is divisible by x minus 1. So we're going to divide the function f of x by its factor of x minus 1. So we have 2x cubed plus 7x squared plus x minus 10, and that's divisible by x minus 1. So let's do the division. X into 2x cubed, leave 2x squared. Then you're going to go 2x squared times x, which is 2x cubed. Then you're going to say, okay, 2x squared times 1, that's minus 2x squared. Then you subtract them. So you go ahead, you subtract them. 2x cubed minus 2x cubed, that cancel. 7x squared minus 2x squared, that's positive 9x squared. So we have 9x squared. We bring down the x now to have plus x. X into 9x squared, that leaves 9x. Then 9x times x is 9x squared. Then we're going to go 9x times minus 1. That's minus 9x. Then we're going to do our subtraction again. Subtracting, we're going to get x minus minus 9 is positive 10x. So we have positive 10x minus 10. Then x into 10x, that is now positive 10. And then x times 10 is 10x. Minus, now 10 times minus 1 is minus 10. Then we do our subtraction. We get 0. All right, so now we have the quadratic factor. So of course we can then rewrite f of x now as f of x is equal to, f of x is now going to be equal to x minus 1 times its quadratic factor of 2x squared plus 9x plus 10. And then we can go ahead now and factorize this quadratic portion, or this quadratic factor of f of x. This is now easy to factorize. So we're finally almost finished. So we're going to factorize the quadratic aspect now, or the quadratic portion of it. So let's factorize it. We know it's going to be 2 linear factors. All right, so in order for it to be 10 and 2x squared, it's going to be 2x and x. Signs are the same and both of them are positive, so it has to be 5 and 2. Both of them are positive. Now let's check it. This times this is that. This times this is 4x plus 5x plus 10. Yes, this is fine. So this is the answer. X minus 1 2x plus 5, x plus 2. All right. So these are the factors of f of x. All right, nice and easy. So let me write it down in part 2. This is part 2. That's the answer. Those are the factors. Nice. Now look at part B. Part B says find the integers x and y such that the square root of x plus the square root of y, so you have the square root of x plus the square root of y, and they told us it is equal to 16 plus the square root of, that's root 240. So you have root x plus root y squared is equal to 16 plus the square root of 240. All right. Now, if you're to expand this square, it's going to be first term square. So you get x plus twice the product of the 2. It's going to become 2 times the root of x times y plus the second term square plus the root of y squared, which is y. And that's going to be equal to 16 plus, to break down the square root of 240, I can rewrite it as the square root of, I'm going to use 4 times the square root of 60. All right, nice. Now I noticed that I have something right here without square root on the left and something with square root, and on the over here too I have something with square root and without square root. So I'm just going to group them together as x plus y. So I'm grouping the terms without square root, x plus y plus 2 times the root of xy, and that is equal to 16 plus the square root of 4 is 2 times the root of 60. Nice and easy. Now look at this now. If two things are equal to each other, if x plus y plus 2 root xy is equal to 16 plus 2 root 60, then what is that telling me? That is then telling me that x plus y must be equal to 16, and that is also telling me that 2 root xy must be equal to 2 root 60. So that's how I'm going to solve for x and y. So if x plus y is equal to 16, and then from this it's telling me that 2 times the square root of xy is equal to 2 times the square root of 60. That's what that is telling me. Now if 2 times the square root of xy is equal to 2 times the square root of 60, then really and truly the next equation they're getting at is just that x times y is equal to 60. Nice. Now if x plus y is 16 and x times y is 60, the only possible solutions are x equal 10, y equal 6, or y equal 6 and x equal, or x equals 6 and y equal 10. 10 plus 16 is 16, and 10 times 6 is 60. So that's the only solution. Let's write that down. So the solution, so the solutions are going to be x is equal to 6 and y is equal to 10. That's one possibility. Or the next solution is x equal to 10 and y equal to 6. Too easy, soft. And that takes care of part B. So you see what is nice? Nothing too stressful so far. Nice and easy. Now let's go ahead now, and we are going to look at the next portion of the question, which is part C. Now part C, it says that solve for real values of x, the inequality, where they give us the modulus of 3x minus 7 is less than or equal to 5. Now, if the modulus of 3x minus 7 is less than or equal to 5, then what we do then is, what this is telling us then is that 3x minus 7 is going to be less than or equal to 5, but greater than or equal to negative 5. We can then add 7 to both sides to get that 3x is going to be less than or equal to, adding 7 to this side, you get 12. Adding 7 to this side, 7 minus 5, I believe that is 2. 7 minus 5 is 2. Then you divide through by 3 to get that x is going to be less than or equal to 4, but greater than or equal to 2 divided by 3. All right, so that is the solution for this question. Nice. So that's that. Now part 2. This is part 1. Now let's have a look at part 2. Part 2, it is saying that show that no real solution for x exists for the inequality. The modulus of 3x minus 7 plus 5 is less than or equal to 0. So the modulus of 3x minus 7 plus 5 is less than or equal to 0. Show that this has no solution. Now to show that this has no solution, all you have to do is subtract 5 from both sides and you're going to get the norm of, or the modulus of 3x minus 7, and you're going to get that that is less than or equal to negative 5. All right, but we know that modulus cannot be negative, so you can write that, but you can tell them, but the mod of a, all right, where a is some real number, is always greater, the mod of a is always greater than or equal to 0. So hence, the modulus of 3x minus 7, the modulus of 3x minus 7 can never be less than 0. All right, so hence that has no solution. Finally, hence the norm of 3x minus 7, modulus of that being less than or equal to 0, this has no solution. Oh, this shouldn't be 0. This shouldn't be 0. This should be minus 5. Minus 5 has no solution. So that's the real reason, because we know modulus cannot be negative. So this has no solution. I'm going to write no sol, which means no solution. Nice and easy, and that takes care of question 1. Easy, 25 marks. Let's have a crack at question 2. Question 2 says, the function f on real number is defined by f of x is x squared minus 3. So let us write that down. It tells us that f of x is x squared minus 3. Now, if f of x is x squared minus 3, we know that it's a quadratic function that turns on the y-axis, and it turns at the y-axis intercept. What else? But it don't even ask for that. It just asking to find f of x. So f of x means you substitute f into f. So f of x is going to be equal to f of x is x squared. So you're going to put f of x into f to get x squared minus 3. All of this squared, and then you subtract 3. Now, since it says 3 marks, it would make sense only to expand it out. So it's going to be first term square, which is x to the 4, minus twice the product of the 2. 3 times 2 is 6, so it is minus 6x squared, plus the second term square. 3 squared is 9, and then you subtract 3. All right? And so what we're getting is that f of x is actually working out to be x squared minus 3 all squared. Then 9 minus 3 is plus. Wait, why am I writing this? Apologies. So getting x to the 4 minus 6x squared plus 6. X to the 4 minus 6x squared plus 6. That is f of x. That's the answer. All right, let's look at the next part now. The next part of the question, it is saying now, solve for values of x where f of x is equal to f of x plus 3. Now we just find what is f of x, right? So before I even solve the equation, I just want to write down what is f of x plus 3. So I'm just going to write down what is f of x plus 3. To find what is f of x plus 3, you replace x with x plus 3. So replacing x with x plus 3, we're going to get x plus 3 all squared. We're going to get x plus 3 all squared and subtract 3. All right, now let's work this out. X plus 3 all squared subtracting 3, it is first term square plus twice the product of the 2, which is plus 6x, plus the second term square, which is plus 9, minus 3. So now that we have f of x plus 3, now we can actually solve what is f of x equal to f of x plus 3. Because f of x plus 3 is just x squared plus 6x plus 6. So this looks very easy to solve. Baby question to solve. Let us boil up this question now. So boiling up this question, we have solving f of x equal to f of x plus 3, which is too nice and easy. Solving this, f of x is equal to f of x plus 3. Solving this now, what we're getting is f of x. As we know, f of x is x to the 4th minus 6x squared plus 6. And we're setting it equal to f of x plus 3. f of x plus 3, it is x squared plus 6x plus 6. So now all we're going to have to do is, we're going to have to bring everything to one side and set it equal to 0. So I'm going to bring everything to the right side, and I'm going to get x to the 4 minus, now bringing over x squared, I'm going to get minus 7x squared. Bringing over 6x, I'm going to get minus 6x. Bringing over 6, I'm going to get 0. And so that's equal to 0. X to the 4 minus 7x squared minus 6x equals 0. I can then go ahead and factorize out x to get x times x cubed minus 7x minus 6, and that is now equal to 0. So now what do I have? I have a cubic equation that I'm gonna have to somehow solve for the values of x. Because I already know one solution is x equals 0. So let's focus now on this cubic equation. To solve a cubic equation, you need to first find a root. You need to use trial and error to find the root. All right, so we're gonna try, let's try x equal 2 cubed minus 7 times 2 minus 6. Let's try minus 2 cubed minus 7 times minus 2 minus 6. So if that works. All right, so I'm trying x equal to minus 2. Try x equal to minus 2. When you try x equal to minus 2 for this cubic portion, right? Try x equal to minus 2, you're going to get minus 2 cubed minus 7 times minus 2 minus 6. You're going to get that is equal to 0. And so if x equal negative 2 is a root, so we can tick it, that implies that x plus 2 is a factor. So x plus 2 is a factor. Since x equal negative 2 is a root, x plus 2 is a factor. Is a factor of what? It's a factor of that cubic expression. All right. And so now we're going to do polynomial division. All right. Let's see if we can make some space right here. Let's make some space. It's making some space to do the polynomial division. Let's do it right here. All right, so we're going to do this polynomial division now. So we're dividing the cubic equation, and the cubic equation is x cubed minus 7x minus 6. All right, and it is being divided by x plus 2. So now x plus 2 into x cubed, x into x cubed, leave x squared. And then x times x squared is x cubed. And then x squared times 2x squared, that is just 2x squared. We're going to do the subtraction now. X cubed minus x cubed cancel. And so we get minus 2x squared minus 7x. Then we're going to say x into minus 2x squared, that's minus 2x. Then x times minus 2x is minus 2x squared. Minus 2x times 2 is minus 4x. And then, of course, we do our subtracting. After we subtract these now, what we get is minus 7x minus minus 4x, minus and minus become plus. So we have 4x. Minus 7x plus 4x is minus 3x. Minus 6. And then x into minus 3x is minus 3. And then x times minus 3 is minus 3x. Minus 3 times 2 is minus 6. Then we do our subtracting. We get 0. Nice and easy. All right, so what does that mean? That means that this function f of x equal to f of x plus 3 is going to reduce to, we're picking up from here now, picking up from right here. This equation can be reduced to x times x plus 2 times the quadratic of x squared minus 2x minus 3 is equal to 0. That's what that reduces to. So now when you're solving this now, what are we going to get? From this, the solutions are going to be x is equal to 0, or x look like it can be negative 2, or from here now, if you were to go ahead and factorize it, you would get x minus 3 and x. That looks like x minus 3 and x plus 1. And so then x is also equal to negative 1, or x is equal to 3. So you're getting many solutions right here. All right, you're getting a whole of 4. All right, nice and easy, soft. Now, if you don't believe your answer, you can check it. How do you check your answer? Give a value out as x as 3. So that means that f of 3 supposed to equal to f of 6. You can check it. Check it. F of 3, work out f of 3, it is 3 squared minus 3, which is 6. Then you work out what is f of 6. F of 6 is 6 squared minus 3, which is 33. Then find out what is f of 6. F of 6 is 33. So you're nice. So they are correct. All right? You're all correct. That takes care of this part of the question. Part B. Part B gives us a quadratic equation. It says the roots of the equation 4x squared minus 3x plus 1 equals 0, and the roots are alpha and beta. Write without solving the equation, write down alpha plus beta and alpha beta. So let's go ahead and do that. So alpha plus beta is equal to minus b over a. So alpha plus beta is going to be minus 3 over a, which is 4. All right, and so alpha plus beta is 3 over 4. That's writing down alpha beta. Alpha plus beta. Next we need is alpha beta. Alpha beta is equal to c over a, and so alpha beta is equal to 1 over 4. That's alpha beta. Nice. Now the next part of the question says, find the values of alpha squared plus beta squared. So let's work out that. Alpha squared plus beta squared. Now alpha squared plus beta squared, there's a simple formula to work this out. It's equal to alpha plus beta all squared minus 2 alpha beta. So alpha plus beta all squared is equal to alpha plus beta all squared minus 2 alpha beta. Nice and easy. So all you have to do now is put in what is alpha plus beta. We know alpha plus beta is 3/4. So put in a calculator 3/4 square minus 2 times alpha beta, which is minus 2 times 1/4. And then you're good. That's going to give you the value for alpha square plus beta square. So work that out. That is 3/4 square minus 2 times 1/4. That's going to be 1 over 60. So that's alpha square plus beta square. Next, part 3. Part 3 says, obtain a quadratic equation whose roots are 2 over alpha square and 2 over beta square. So to obtain a quadratic equation of 2 over alpha square plus 2 over beta square. So if you want a new quadratic equation, we know that a quadratic equation is always written in the form x squared minus the sum of the roots times x plus the product of the roots, that's equal to 0. So first we need to find is the sum of the roots. The sum of the roots would be 2 over alpha squared plus 2 over beta squared. Now, whenever you have two fractions and their denominators are the same, what do? You find the LCM. We'll go back to primary school. The LCM is going to be alpha square beta square. Now, alpha square into alpha square beta square leave beta square. So this is going to work out to be 2 beta square plus beta square into alpha square beta square leave alpha square. So this is 2 beta square alpha square. So this works out to be 2 times alpha square plus beta square. That's how we get the sum. This works out to be 2 times alpha square plus beta square. And it is, of course, being divided by alpha square beta square is alpha beta all square. Alpha beta all square. Nice and easy. But we just find out what is alpha square plus beta square. Alpha square plus beta square will work out to be 1 over 16. So this is 2 times 1 over 16. 2 times 1 over 16. And of course, it is being divided by alpha beta all square. And alpha beta all square. Alpha beta is 1 over 4. So it is being divided by 1 over 4 square. So you put this in a calculator and you work it out. What are we getting? 2 times 1 over 16 is 1 over 8, and 1 over 8 is divided by a quarter square. This works out to be 2. So the sum of these two works out to be 2. Next we need to find is the product. All right. Let's split it here and find the product. So the product P is going to work out to be 2 over alpha square times 2 over beta square. That's how we get the product of the two roots. 2 over alpha square times 2 over beta square. Now when you're multiplying two fractions, you multiply across their numerator. 2 times 2 is 4. Now alpha square times beta square is alpha beta all square. This is alpha beta all square. All right, and so the product works out to be alpha beta all square. Remember, alpha beta all square. Alpha beta is a quarter, so it works out to be 4 divided by a quarter square. You put that in a calculator. Well, you don't have to. You can work it out in your head, but just put it in a calculator. So 4 divided by a quarter square, and you get 64. So you get 64. That's the product. So what are we saying then? We are then saying that the quadratic equation, so I'm going to write the new quadratic equation, the new QE is given by x squared minus the sum of the roots, which is minus 2x plus the product of the roots plus 64, and that is equal to 0. So this is how you would find, or this is how you would work out that. Nice and easy, soft. Okay, let's look at the next part of the question. The next part of question 2, part C, it wants us to Without using a calculator, evaluate the following. Without using a calculator. All right, so without using a calculator, evaluate log to base 10 of 1 over 3 plus log to base 10 of 3 over 5, and it continue. Log to base 10 of 1 over 3 plus log to base 10 of, that's not 5 over 3, that's 3 over 5, my apologies. Now, anytime you see logs question, the only thing I can say is start to think of the rules of logarithm. Always start to think of the rules of logarithm. We know what the rules of logarithm are. The rules of logarithm tell us that log A plus log B is the log of AB. All right. And we know that the log of A minus the log of B is the log of A over B. And finally, we know that the log of A raised to some power n is equal to n log A. So start to think of all of these rules of logarithm. Anytime you're going to evaluate some log without a calculator, you want to utilize the rules. All right, so let's look at this. So this is going to be equal to log to base 10 of, all of them have the same base, and so this is like your A, B, C, D, E. Now log A plus log B is the log of A times B. So all of this is going to work out to log to base 10 of 1 over 3 times 3 over 5 times 5 over 7 times 7 over 9 times 9 over 10. All right. That's what this question is working out to be. Now, one thing I want you to realize is that anytime you're doing this type of multiplication, you notice that this 3 cancels this 3, this 5 cancels this 5, this 7 cancels this 7, this 9 cancels this 9. And so what we end up working with is that we end up having the log of 1 over 10. We end up have the log to base 10 of 1 over 10. All right, log to base 10 of 1 over 10. Now that we have log to base 10 of 1 over 10, that is equal to log A over B is going to be log to base 10 of 1 minus log to base 10 of 10. Now right here, so you can put it in a calculator, log to base 10 of 1, which is 0. Let me check that just to be sure. The log of 1 is 0 and the log of 10 is 1. So this works out to be 0 minus 1. And 0 minus 1 is negative 1. And that's the answer for that question. Nice and easy and soft. That's part 1. Now let's evaluate part 2. Evaluating part 2, we're asked to evaluate the sum from r equal 1 to 99, r equal 1 to 99 of log to base 10, log to base 10 of r over r plus 1. So let's see how we're going to do this. To do this now, the best way to do these type of question is, of course, you're going to evaluate it. So you're going to plug in when r is 1. You notice that when r is 1, you're going to get 1 over 1 plus 1 is 2. Plus when r is 2, you're going to get 2 over 3. Oh, I forgot to write log. My apologies. Forgot it's not regular sum. This is log sum. So it's going to be equal to the log of r as 1 So it's 1 over 2. So add in the log of a half plus, put in r as 2, you get in the log of 2 over 3. Put in r as 3, you get in 3 over 4. They're going to get 4 over 5. They're going to get 5 over 6. They're going to get 6 over 7. They're going to get all the way down and down and down and down and down. And so I'm going to stop right here. I'm just going to put some dots to represent what we would get. All the way down to the last term, I will get the log of, when r is 99, I'm going to get 99 over 100. A lot of work. Now to evaluate this log again, we're just going to utilize the same principle that we said. Log A plus log B is a log of AB. So all of this is going to work out to be log to base 10 of a half multiplied by 2 over 3 multiplied by 3 over 4 multiplied by 4 over 5 multiplied by 5 over 6 multiplied by all the way down to multiplied by 99 over 100. All right, nice and easy. Now, what's going to happen now is a half times 2 over 3, these two cancel, these 3 cancel, the 3 over 4 going to cancel with the 4 over 5, the 98 over 99, 99 will cancel there, and so all of this is going to just work out to be log to base 10 of 1 over 100, log to base 10 of 1 over 100. Now log to base 10 of 1 over 100 is equal to, you can write it now as the log of 1 minus the log of 100. And you can put that in your calculator. Log 1 minus the log of 100. And you get negative 2. So the final answer is negative 2. Nice and easy. So that's the final answer. Too easy, easy, easy. Soft. Nice. Now that takes care of module 1. And then now we'll move on to the best module in mathematics, module 2. Module 2. Module 2, of course, usually starts with trigonometry.